Good afternoon. Welcome to the second lessons in a series of how to build a bus. Now, I hope that you would have read the slides that I put up on REST, number one, and I think I put up another slide on the services that a bus offer. Now, let us ensure, so the purpose of this second lesson is to ensure that you understand or to form some type of discussion about about REST services and why we need them, why REST is so important. Now we would have done SOAP before, and SOAP is important as well. But SOAP services basically model the world in terms of actions. So you will have a SOAP service and a SOAP inventory, some type of inventory service that says update, get wages, update history, delete history. So every object has its own actions, and this modeling of the world can get very, very complex in the sense that a programmer now have to think about every single object having its own actions. In the REST world, you have something called a URI, which is a unique identifier that only identifies that resource. And no matter where you are in the world, you can get to that resource using that unique identifier. In fact, it's very similar to a web page, and a web page is a form of a URI in a way, because no matter where you are in the world and you type in a unique a web address, it will get you to a unique web page, and that web page can be seen as a resource. Similarly, a URI gets you to a unique resource. In the REST world, however, though, a resource only has 4 actions. There are only 4 possible things you can do with a resource. You can create the resource, you can read the resource, you can update the resource, or you can delete the resource. So the REST world is modeled in terms of 4 verbs. So every single object in this world is made up of 4 verbs. So that's the REST architecture. Now REST basically is an architecture that allows you to transfer the state of an object, and primarily that the state of an object is transferred from the server to the client. So if you have an object on the server and the client wants to do something to it, the server will transfer the object from the server over to the client. The client will perform the state changes and then reload the object itself over back to the server. As I was saying before, the resources are identified using a uniform resource identifier, and the engine of transport is primarily hypertext, which is the HTTP protocol. And the HTTP protocol, the nice thing about REST is that the HTTP protocol was in place before, and the REST model just sits on top of that. And it is client server in nature. It is stateless, and more important, and a very important property about the REST model is that it allows us to cache, and we know that caching web pages are important because it saves time going out to fetch the same thing again. So the REST model naturally allows that. Resources are first-class objects. Resources are retrieved not as characters or strings or blocks, but as complete representations. State is always preserved, and REST messages are primarily can use any medium. It can use text, it can use XML, it can use something that we are going to be talking about a lot in this course, JSON format, and any format can work with REST. That's the nice thing about REST. Whilst in the case of SOAP, we are restricted to XML. We have to use XML in order to communicate our messages from server to the client. But in REST, we are open to anything that we want to use. So, unlike SOAP, right, you're not fixed to a REST format. You can have multiple representations. Let me just go through this slide. You can read all of this in your spare time. Why REST arguments for non-REST designs against non-REST designs? Designs like SOAP. SOAP don't naturally support caching. SOAP don't scale well. And it has a higher coordination cost. SOAP primarily runs on top of TCP. And TCP basically, in order for you to use TCP, you have to use some higher level protocol first. So it means that the programmers have to do more work. A programmer will have to do more work in order to use something like SOAP. Whilst every programmer wants to use REST, he simply uses HTTP. But we all know that HTTP is available to everyone via a web browser. So it's much easier to use REST services as well. A service offered in REST style will inherently be easier to consume. There's a lower learning curve for the consumer because it's basically HTTP, and lower support overhead for the producer. That is, the person who's producing the service don't have to worry about writing things like handlers for TCP, etc., etc., etc. REST is one misperception about REST is that it may not be enough. How can you model the world only in terms of get, puts, and posts and delete? And the real thing about it is that there's no application. And I've thought very hard about this, and it has never occurred where I can model in terms of get, puts, posts, and delete. Almost everything the world can be modeled in terms of those four things. And basically, that's the end of this lesson, which is just to basically sensitize you to REST itself. The next lesson, I'm now going to show you how to use Coordinator to consume SOAP and produce REST services. Thanks.